that you can have as many balcony seats as you want. That doesn't make sense. But because they want us to start off with this, this is what we're going to do. And we go to that apps button, inspire people. Do you know if you have any quality stuff on yours? So you're able to do it. Good, good. So we go into apps. Back down here, because I have lots of apps on mine. N equals, there we go. And then it just says press any key, so usually I'll just hit enter. But what this does is it allows us to change the equals to greater than or equal to, less than or equal to. But like we encountered before, whatever we're going to put in our calculator has to be y equals. So we do have to do a little math to get it into that form. So the top one here is not solved for y, it's not ready to go. So we would say I am going to subtract 20x from both sides. And then I'm going to divide everything by 30. Now we could physically do that division if we want to, but we wouldn't have to. We could just put this in with parentheses so that the calculator knows, take all this stuff on the top and divide it by 30. So it gets to the point where you're thinking, do I have to do a lot of this by hand? You would not have to. You put it in just like that. But negative 20 over 30 will give us negative 2/3 x. And dividing this by 30 would take one of those zeros off, and then 3 divided by 3 would be 1, so that would be 1,000. So you don't have to. In fact, you know what? I'm going to put it in without it on there. So we've got this little bugger right here, and this equation put in so that we can see where these should be the double shading. Now what we have to do is get the graphing calculator to get that less than or equal. And to do that, you can't, I know the gray buttons, it looks like I should just be able to press those and that's going to give me what I need. You have to press the green alpha button first before you do that. So we'll do green alpha and then less than or equal to, which is going to be the zoom button. And then all you have to do is arrow to the right. Now notice on the left hand side it's showing you this is how I'm going to shade. I'm going to shade this really dark black over here. And we just want this one to be 500. Cassandra, did you get the one without the n equals on it? Yeah. Ah! Of all the calculators, I have 7. All right. Well, at least I know which one it is now. Put a piece of masking tape on it. Yeah, this one has it. All right, here you go. All right, then the next one we have, like I said, I'm just going to put the whole thing in there. We've got our y is greater than or equal to. So I'm going to go back to the equals, just hitting that left arrow once. And then we need to pick the alpha graph button this time, so we can get that one to change. And negative 20x plus 30,000 divided by 30. I could put the simplified one in there, but I don't have to. So now, obviously we're going to need to change our window. We're talking here about real life stuff. So I go to window, and I'm not going to mess with the shading. That's the calculator doing that. If you want it lighter, you can lower number down, that kind of thing, but we're not going to mess with that. But I do know that this is talking about our y values as seats, and we have to have the x values to make that happen, and that's balcony seats. So I think, well, if they have 500 orchestra seats, they must have a lot of balcony seats. What's up, Bo? Oh, that's a good. So just go down to the X min. We'll start there. So we'll start with 0 balcony seats for the X min, and maybe 2,000. Should be lots of balcony seats compared to orchestra seats. X scales, it can go by ones, I don't care. And then my Y min, well, that was the money that we're trying to see here. And we've got actually our Y value, the money for $30,000 was using that 500 for the orchestra seats. So maybe I'll try 600. Because remember, they're getting money from the X's and the Y's together, but it's about the seats. That's what we defined our variables as. And then let's hit graph. So there is our Y is less than or equal to 500. And there comes the double shading region that we would want to see. So on the homework, we could really just make a sketch. But if this is on a test, we want things labeled nicely. So really, we're going to do quite a bit of this by hand anyway. It's just kind of nice to see a visual of that before we start. So we know that our Y's are going to have to go up to at least 500 so that we can see where that intersection is. But we also know these are both positive values. And we've got our little 20 by 20 here again. So maybe I'll make every 4 of these 100. And then we might want to use the fact that we can see that up there, and there's so many different ways to get the second piece, you know, because we certainly could use this and say we're going to go up 1,000 and down 2 and over 3, but that's not going to give us what we want, which is really our zeros down here. So by hand, I would probably just go right back up to the beginning. Because then I'll know exactly where I need to go, looking at my x-axis over there. Say, hey, I'll find my zeros, and I'll be able to see what I should label those x's as. So if this is a 0, we have 30 times something needs to come out to be 30,000. Well, that's 1,000. And then if we look at this one, we'd say, okay, well, if this is 0, now I'll need 30,000 divided by 20, or 3,000 divided by 2, which is 1,500. So when I'm graphing down here, I need to go to at least 1,500 to get that piece on there. And I have 20 to look at, so maybe I will do this. So,
what zoom should it
not zoom. We set the window so we could see the balcony and orchestra seats. So we did 0 to 600. 0 to 2,000. Oh goodness. Oh. That's why it's so confusing. All right, so 1,500 0 right here. And then as we look at the graph, you start thinking, well, what should I aim at? Well, we've got the graphing calculator, so maybe if we hit trace, we could at least get something to aim at. You see how I'm just moving Blinky to see a spot where we could aim at what's going on? So this one says at 766 or so, 500. Up farther. And now we can make a pretty good sketch of what's going on. So both of these have the equals bar. And we might just say, you know what, I know the shading this way, but I really want to overdo my shading over here anyway. everybody knows, hey, this is where the solutions would be.
It's exactly 750.
Oh, with your inspires, you
Yeah.
can get it perfect. It was exactly what?
Like you can do the intersection of them.
Oh, okay, so you use Blinky to find it? Because I'm not going by units of one, I really just needed something to aim at. But yeah, if you can use the intersection, I wonder if Blinky will do that. I've never tried it with inequalities before. Is Blinky smart enough to know how to get those intersections? Blinky is smart enough. So something to aim at is what we needed. Because our graph is not, we didn't go by ones or anything. It's not perfect. But it doesn't need to be perfect because we just need to show everybody over here, is where we're going to have those solutions. Now, as we're going through this, you see there was quite a bit of math we had to do by hand anyway. So if you're worried, I don't like using the graphing calculator for this, I really don't want to use the graphing calculator, you don't have to. You can do it by hand. We can always have that y equals mx plus b form or our standard form and get it by hand. Because maybe your calculator doesn't even have the inequalities on there yet. So this one says, how many of each type of seat must they sell? Well, we're just going to show it as a graph. There's too many for us to tell them. There's an infinite amount of them. Until they tell us how many balcony seats are available, we really can't give them that information. So that's what we would do. We would graph it. So now, one maybe with a few smaller numbers would be good. Something, that when we graph it, we can be a little more detailed with to see where those are going to happen. So we've got pizza parlor here. Ooh, and I'm guessing that takes a lot of battery power for Blinky to sit up there with that. So I'm going to turn that on. Pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. Okay? You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? All right, so the question is how many of each type, which would mean we better have our variables be veggies and meats. But I'm hoping that we can see some totals up there. Catch a total? $10. Sounds like a good total. So, can you spend $11? No, so you can't go higher. Can you have exactly $10? You could, we want to put tax and that kind of thing. I guess we're assuming in this one there's no tax on any of this. And this was about money. So what do we know about money with the veggies? It's $1. How about the meats?
$2.
$2. There's a total up there somewhere. If we have 2 variables, we need 2 inequalities in order to solve this. Where's the other total? At least 5 toppings. So would 4 be at least 5 toppings? Okay, so we can't use less than. Could you have exactly 5 toppings for at least? Does it say you have to get twice as many veggies as you do meats or 3 times as many meats? So what do we do over there? Exactly, Justin's got it. This happens all the time with these word problems. We're looking around thinking, there's got to be some more information here. There isn't. That's it. So we've got the money, less than or equal to 10. And x plus y has to be greater than or equal to 5. And this one we can do a much better, more defined job on because this is going to talk about something that's going to fit in like our negative 10 to 10 window. In fact, we really are only going to need the first quadrant here to get what we need. So the top one, we would use the zeros with the standard form. And you could actually think through this as the word problem. You could say, hey, if I don't get any veggies, what can I get for meats? For that $10. How many meats could you pick? 5 if they have them, yeah. We've got 5 meats available. If you don't get any meats, how many veggies could you get on your pizza? 10 of them. So 0, 5. 10, 0. Dashed or solid? Solid. Do you have a limitless amount of money? No. So we cannot shade out this way. In fact, we would just stay in first quadrant because we know you can't have a negative amount of veggie toppings and a negative amount of meat toppings. And then we go to this one and say, well, this would also be a really nice problem to work through if we pretend this is equal so we can get that boundary line. So if we put a 0 in for x, what would y have to be? 5. And if we put a 0 in for y, what does x have to be? Works out pretty good. Ooh, dashed or solid? With word problems, we usually end up using that equals a lot. Now, this said greater than or equal to 5 toppings. So where are we shading for the red one? Yeah, it's got to go up. So in reality, are there a limitless amount? No, because this is going to be whole number answers. It would be any of our whole number answers in here. That would give us our solution. And notice it forms a little triangle. And that's going to hook into what we do in 3-4 when we try to figure that out. So we could write down all of the positive whole number solutions in this, but you know what? Graphically, anybody should be able to just do some counting and figure out what they would be when we get in there. Used to be in health class, I don't know if they still have you do this, people had to make a poster about heartbeats per minute and where your peak performance level is, and did graphs like this to show, hey, it's right in this zone where you'll be okay. So these are really helpful for people that are trying to figure out, okay, where can I work with this stuff? Now, the one thing we didn't do was we didn't take a look at absolute value inequalities, and we graphed those earlier in this chapter, so we have already done this. And we want to see how does that work when you're graphing linear and absolute value at the same time. So the top one here, I'll do this one with green, says y is less than or equal to 3. And I remember that lines get their name from which axis they karate chop. So this one's karate chopping the y-axis. That makes it a horizontal line. And it does have an equals bar, so I'm going to go make my horizontal line right there. And since it says less than or equal to, that's going to be shading down. Again, you can do a much better job of shading if you've got a colored pencil to go through. Then I look at the second one. And I remember that form, the H and K form. And I also remember that whatever's inside those absolute value, just grouping brackets, quite frankly, it could be parentheses, absolute value, whatever it is, I always have to think opposite. So which way is this going? Going to the right. So our new starting place for this absolute value, our new vertex, is at 1, 0. And the slope of the right side, do you remember that? What would it be? Imaginary 1 up there. Up 1 and over 1. And then you can either use the slope backwards, or you could go ahead and use symmetry through that line of x equals 1. Dashed or solid? Solid. Shading up or down? Yep, this one's up. We've got greater than. What's the shape where our solutions are for this one? Another triangle, yeah. So overshade this triangle region right here. Big time. Overshade that region. So we can do these. It's something we've already done. It's just starting to look a little crazy because there's a lot to keep track of. So let's take a look at the got it. And I'll start with green. So how would you graph that? Where do you start? Fine, I'll call on you because I can see you're doing this. All right, Bryce, where did you start?
0, 1.
Yeah, and then where did you go?
Then I made points at 0, 3, and made 3, 2.
So you went down 1 and right 3, and then you went back 3 and up 1. Okay, so everybody, should this be dashed or solid? Yeah, this one's dashed. We haven't had to do that for a little while, so we got to dash that little bugger. Shading up or down? Yeah, this one's is solve for y, so when it's less than, shading down. All right, I'm going to want to know where our new vertex is for this little bugger right here. Careful. Where's the new vertex? 1 to the right. Yeah, whenever it's connected to the x, that's our right or left, and it's always the opposite. So 1 to the right. New slope. What's the new slope? Up 2 and over 1. And then again, we can use the slope backwards. Dashed or solid? That's hard to remember, especially there's so much going on here, but we have to check for that. Up or down? Up. Does this have an intersection? Really teeny one, isn't it? Right here. That's it. That's the only spot that's going to be red and green is that little spot right there. All right. I have always wondered whether or not it's even worth it using the inequalities app on the graphing calculator. You don't have to use it. You could certainly do all of these by hand, so know that. How many of you thought, yeah, it's pretty cool that this thing is doing this on the graphing calculator? Okay, so you could absolutely use it. But now, every time you go back in here until we turn that app off, you're always going to have to change this back to equals, which means alpha y equals, you know, if you want to do normal graphing. So what you can do is second plus number 7 and just reset your memory. Otherwise, you can go back into the program itself under apps and you can turn it off. Then that won't be there every time. So it's one of those things where I know we're supposed to use it and you're supposed to be able to see it and all that kind of stuff, but really often it is much faster to just graph by hand. So how do you feel about graphing inequalities now? Our objective was to graph all of these. 4, 3, 2, 1, 0 mean. How do you feel about all of this? Okay. So it's there. If you want to use it, use it. If you don't, don't. It's okay. Remember, you should be able to go back now and do number 20 and do that word problem, although it looked like a lot of you already did it anyway. But now we have some new stuff. Thinking back to that health assignment, it was about heart rate and it was about blood pressure and peak performance areas for athletes is what it was about. And I know that the health classes now do tons on the Chromebook, so I don't know if they even still have people do that. But they used to have them make a poster to show people, you know, here's where you should be exercising. And that's a great way to use those inequalities.